All right, y'all. We have now figured out the definition of congruent figures, which is two geometric figures that have exactly the same shape and size, but probably more technically, what we want to know is that if two figures are congruent, all of their corresponding sides are congruent, all of their corresponding angles are congruent, all of their corresponding parts. So if you have a decagon, there would be 10 pairs of corresponding congruent sides and 10 pairs of corresponding congruent angles. With triangles, it's a little bit more simpler because we only have 3 sides and 3 angles, a total of 6 parts, and that's what we see right here. If two figures are congruent, all pairs of corresponding sides and all pairs of corresponding angles are congruent. And so does that mean that to prove two figures are congruent, we have to come up with all of this information? Well, we start talking about shortcuts, and one of the shortcuts, the first shortcut is the side-side-side shortcut. And we're gonna actually construct a triangle using side-side-side. How would you do that? Well, a side is just a segment. And we learned early in the semester, the very first construction we learned was duplicating a segment. And that's really all we need to do. We just need to do it 3 times because triangles have 3 sides. So let's go ahead and get started here. The first thing we want to do is, using your straight edge, create a ray. So I kind of cheated a little bit and I did that one ahead of time, but here we'll pretend I haven't done it yet. And we'll do it again. Ready? Here's my straight edge. There's my ray. I now have a ray ready to roll. Okay? Step 2. You pick any of the 3 sides, doesn't matter which one, and duplicate one of those segments on your ray. So far, this is really just going back to earlier in the semester and reproducing that very first construction we learned, duplicate a segment. So we'll get the edge put up there. We'll open her up to get that length. Perfect. All right. And now that we have that length, we'll go over to our array and we'll duplicate that length. That is how you create a segment, right? Notice we want to put points on our endpoints. Why? Well, we're building a triangle here. Triangles have vertices. It's just kind of nice to know where those vertices are. We put the point of the compass there. We marked out to here. Those are 2 of the 3 vertices of our triangle. Okay, but we still have 2 more sides that we need to create. And so what are we going to do next? Well, we're going to now go to a second side length, and from one of the endpoints that we have established on our ray down there, we're going to measure that segment out. Okay, so I'm just going to go right down to the next length. It really doesn't matter if you start with the longest or the shortest. It's really kind of a little bit of a personal preference which one you want to do. Just rotate this up a little bit. Further out, right? And I think we got it. Okay, so there's the length of our second side, and I'm just going to come to this first endpoint right here, and I'm going to just make a nice arc up across here. I don't know where exactly along that arc that third vertex is, but it's somewhere along that arc. You know, it may be down here, it may be up here. I just want to make sure I make this arc long enough that when I'm looking for the length of the third side, I've made enough of an arc that I get an intersection. And I think I've got plenty of arc there, so let's go ahead and continue on to the next step, which is, using your compass, measure the remaining side length, that third and final side length. So I'm going to come over here to our last length, in this case the shortest, and copy its length with my compass. It's going to be right around there. I think we can go out. There we go. So there we go. There's that length right there. So I'm going to go to the last remaining endpoint that I haven't used, the second one. And then I'm just going to do exactly what I did before, which is I'm going to make an arc. And guess what? Where those two arcs intersect is our final vertex. So we're going to go ahead and put our final vertex there. And to create the triangle that we've been looking for, all we really need to do now is, using your straight edge, connect the new intersection point, our new vertex, with each of the other two endpoints we'd already found. So I use one of these lines for my straight edge. You guys would obviously use a straight edge. But this creates the two missing sides of our triangle. And we have now copied these three sides right here into this triangle right here. And if you want to see just a little visual, if these are the three side lengths that we started with, you can see how we built that triangle using, oh no, how did that happen? I was probably going too fast. I'll just do these one at a time. Okay, and then here's the last one. There it is. So you can see that we did use those three exact side lengths to build this triangle. And really, it was just a matter of making three arcs, so pretty darn easy. This, because of SSS though, because of the SSS postulate, anybody, anywhere using these exact three lengths would create the exact same triangle. And that's pretty powerful. We know that this triangle would be congruent to any other triangle constructed using these three side lengths. Thanks for watching. Stick around and we'll do the SAS construction coming up pretty soon.